In this video, we'll look at how to find the equation of the tangent using first principles when that equation given to us is a polynomial. So the equation we're given is 3x squared minus 4x. So we'll start by figuring out the derivative using first principles. That is, we're going to take the limit as h approaches 0 of the function f at x plus h when h approaches 0 minus f at x all over h. That's what first principles means. So we're going to find the limit as h approaches 0 of what's f at x plus h, sub x plus h into this whole thing. You get 3x plus h squared minus 4x plus h. That's just me subbing into these x's with the x plus h. And now minus f at x. What's f at x? Sub x into there. You get the same thing back. Minus 3x squared minus 4x. Now careful, make sure to put this whole thing in brackets because we're going to take away all of f at x. And all of that's still over h. So we get the limit as h approaches 0. And now, if you're not sure how, go over another video that teaches you how to FOIL or expand using distributive law. X plus h squared, that's just going to be x squared plus x plus h plus another x plus h is 2xh's plus h squared. That's the expansion of this thing. Still has a 3 in front. I'm going to rainbow this minus 4 in. That is, I'm going to distribute it so I get minus 4x minus 4h. And I'm going to do the same thing with this minus. I get negative 3x squared and plus 4x all over h. Okay, so far so good. Now let's rainbow this 3 in, and I get 3x squared plus 6xh plus 3h squared minus 4x minus 4h minus 3x squared. It looks long, doesn't it? But there's good news. Lots of things should cancel out now if you've done it right. For example, I have a 3x squared here and a negative 3x squared. Those are gone. And I have a minus 4x and a plus 4x, and that's gone as well. So I get the limit as h approaches 0 of 6xh plus 3h squared minus 4h all over h. I'm doing great. Now, I could cancel out the h's one at a time if you can see it. If you can't, what I meant by that last sentence is you can factor out an h on the top. That is, you'll put an h here, factor out of 6xh, you get 6x, and factor out of 3h squared, you get 3h, and minus 4h just becomes minus 4 without the h. Let's close that brackets. And why is that good? Because now you can cancel the h's out. You didn't have to do this factoring step. If you could see it from here, you could cancel this h on the bottom with one h from each of the top terms. Nonetheless, now you get the limit as h approaches 0 of 6x plus 3h minus 4. And now we don't have to worry about the limit anymore. We can actually sub it in. That is, we can evaluate as h approaches 0, this term will become 0. And we get 6x plus 0 minus 4, because what's 3 times 0? Just 0. And the whole reason this worked is because we were able to cancel out this h on the bottom with an h on the top. And we did that by doing all kinds of expanding and then simplifying. And now we're down to 6x minus 4. And therefore, the equation of the tangent, the equation of the derivative, is f prime at x equals 6x minus 4. And that's how to find the equation of the tangent using first principles.